Hi, everyone. I'm Jackie, and I am the head of front-end development at Behance. You can pronounce it however you want, which is an online platform for showcasing and discovering creative work. You can reach me on Twitter at any point at JackieBackwards, which is a tricky username to try and communicate out loud. And I'll also be doing office hours right after this if you want to chat with any of the stuff that I cover today. So first, before I get started, a little bit about me. I joined the Behance team about 8 years ago, and the company as a whole is just about 10 years old, and we were acquired by Adobe about 5 years ago now. So I started as kind of a general front-end developer and doing a little bit of everything across the stack, but over time I've actually grown to focus on our CSS. I work closely with our designers and also thinking about how we structure it across all of our different applications. And so I'm completely all in on front-end development. I have never worked in DevOps. I think when we hear CI/CD, that's typically where our mind goes first. But I did help with the development of the web UI for our continuous integration and deployment platform. And perhaps more importantly, I'm also a regular user and avid fan of it. Our process for getting code to production at Behance over the years, and even to staging, and sometimes even our development environments, has changed drastically over the years. So while this talk is not about Behance, the product, I do want to talk about some of the ways that we have improved our process and culture around deployments on the Behance team over those years. So when we talk about actually deploying code to production, how do we measure the success of that process? I feel like typically it's measured in check marks. We're looking for our automated tests to pass, or code coverage reports, perhaps to close GitHub issues or Jira tickets or whatever your system is. And then as long as the code makes it to production and nothing breaks, we consider that a success. But what if we were actually to consider empathy in the metrics for what makes a good deployment? There's a quote from Compassionate Coding, which is an organization that deals with empathy in software engineering, that says, many teams are in the habit of asking, what is the lean choice here, or what is the agile choice? But how about considering what is the compassionate choice? Given our constraints, how do we minimize suffering? My opinion is that a good CI/CD platform and process is actually the empathetic choice for delivering and deploying code to production. When we write code, we put ourselves out there. We feel good when we make something useful and people are using it, and we make ourselves open to the vulnerability of feedback from our peers and our users. Of course, every engineer wants to work on code that actually makes it to production. And when we talk about software development, I feel like we mostly talk about how to write the most efficient or reusable and optimized code. And then we talk about, once it's out in the world, how to maintain and optimize that code. But what I don't feel like we talk about as much is that messy, meaty middle part of that spectrum of actually getting our code into production. And it's interesting because there's actually a lot of things that can go wrong in that part of the process. Traditionally, the actual act of deploying code to different servers is a pretty highly skilled task that's completed by a DevOps engineer who has pretty specific domain knowledge of a lot of underlying infrastructure and systems and the command line. So if that person isn't you, then the amount of unknowns in the process of doing it yourself is probably kind of terrifying. I know that the first time that I ever wrote a Capistrano script to deploy my personal website, I was so baffled and unclear by what I had just written that even though I eventually hammered it into somehow working, I was so afraid of some esoteric unknown part of this thing going catastrophically wrong. I was literally afraid to update my own website for over a year afterwards. And that's just my personal website, which is not a big deal. So even if you're in a situation where someone can deploy your code for you, there's always the chance that you may have written code that worked in your dev environment but then falls apart in a production scenario. Or everyone's actual worst fear is that it brings down the website entirely. I did once bring down the entire Behance website moments before we were expecting a huge press release. I still have nightmares about it. And of course, nobody wants to feel like they've failed, and failing publicly on the internet is probably even worse. But there's a lot about a good CI/CD platform that we can use to create workflows to reduce the friction and the risks and fears all surrounding actually deploying code to production. So just real quick, what do I mean when I say CI/CD? The goal of continuous integration is to provide rapid feedback so that if a bug is introduced to the code base, it can be identified and corrected as quickly as possible. On the other hand, the goal of continuous deployment is to make feedback loops with the end user as short as possible. Because we're able to deliver code more frequently, we can measure cause and effect on smaller change sets much sooner. And then we can make rapid changes and improvements to features and functionality based on that feedback, which is something that an automated test suite wouldn't really be able to give us any feedback on. It's an industry best practice that has a lot of benefits in terms of reducing risk and allowing for rapid improvements of your product. But it can also entail a lot of opinionated process that may require some shifts in how your teams work to actually get there. So before I go into how we do CI/CD at Behance, I want to give you some background on the very character-building history of deploying to production at Behance over the last 8 years as I know it. So when I joined the team, I was the 5th developer. We were very much in early startup mode at the time, and our primary motivator was simply to get as much code out into the world, hopefully mostly working reasonably well, as quickly as possible, with honestly pretty minimal concern for whatever tech debt we were accruing at that point. We were using Subversion for version control, which is not particularly well-suited to any kind of branching and merging system, which meant that we were all just constantly committing directly to the same branch all the time. I think that we believed that we were being agile by skipping the time-consuming, nitpicky tasks of writing tests or doing peer reviews, which we felt meant that we could turn on a dime on product decisions at any moment. For the record, this is not what it means to do agile development. We didn't have any process for task management, really. I think we had a whiteboard with handwritten Post-it notes that we would move around because I guess having real task management somehow would provide too much overhead. And then every 2 weeks or so, our one DevOps engineer would cut a release from the branch that we'd all been committing to, containing the mountains of code that we'd created over the last couple of weeks. And then they would put it in our staging server, where it would sit for review for a day or two, and then onward to our production servers. And because we were deploying these huge change sets all at once, we recognized the high risk of breaking things in production. So our deployment strategy was to pick a time of day when traffic was lowest and do our deploys during that time so that the effects of any problems that we created were only minimally felt by our users. So what this means is that we were literally anticipating and optimizing for failure. In our case, that meant that we were building at night instead of during the day, during normal business hours. This is an actual photo from one of our build nights. You can tell from the windows it's dark outside, so we're already at work later than we should be. I'm wearing a motorcycle helmet because I'm delirious from being at work for that many hours. Let this be an example of what your deployment process should not look like. So eventually, as the team grew, we hired other DevOps engineers to help automate some of these processes. But what that didn't immediately solve for was the rate at which we were needing to hotfix issues in production. With a growing dev team and a primary MO of still being able to get as much code out the door as fast as possible, we were regularly having to ask our ops staff to cut and deploy release branches for us for our hotfixes. And they were constantly just regularly losing literally days of their time doing nothing but being our personal deployment Sherpas. I highly doubt that this is the kind of menial, repetitive tasks that anyone has in mind when they get into DevOps as a career. And so the strategy obviously just wasn't scaling very well. In addition to that, because of this extremely low-fi system that we had in place, there was also no way for us to do a rollback. So if we pushed a bug forward, we just had to keep moving forward with it. And if it didn't work, wait to resolve it and release another hotfix. Now, this is a pretty scary potential scenario to always have hanging over your head. It means if you break something, it's just going to sit there on the internet, in front of all of your users for them to see until you can figure out the fix and actually get it out there. And of course, for build nights, since all of the changes are batched into one gigantic deployment together, that means that everyone who has changes going into this build has to sit around and wait not only to confirm their changes, but also confirm that, wait for everyone else to confirm that their changes are good before the deployment can continue. At some point along the way, as the team was starting to grow, we switched over to Git and GitHub, which was great because it made code branching and merging way cleaner and opened up much better opportunities for us to peer review code and run our automated tests, which we were at least finally starting to write. We started using Jenkins and Hubot to allow engineers to deploy some of their change sets to our different staging environments. This was actually a really big step for us because it took some of the menial tasks off of ops plate and gave more ownership to engineers who wrote the code. But of course, we still had to ask an ops person to take it all the way into production if it was a hotfix, or for the most part, these things were still waiting until build nights anyway. So although in some ways we were getting closer to a CI/CD platform, we definitely still had a long ways to go. So I think if any of your teams are not using CI/CD, there's probably a good chance that you have a similar process to some of the scenarios that I just described. I talked to a few teams at different companies of varying size and maturity, and I've heard a lot of similar stories. So although these evolutions are promising, there was a lot wrong with them, and we were starting to identify these problems and looking to solve for them. First of all, as I said, these kind of monolithic builds are really high risk. They include too many changes happening all at once, which means too many variables and too many moving parts and chances for things to go wrong. Statistically speaking, according to the State of DevOps report for 2017, which is a very interesting report put out annually by Puppet, they found that low-performing engineering teams release less frequently and with a higher failure rate than high-performing peers, meaning we were clearly on the low-performing end of the spectrum. This kind of build style also tends to create a throw-it-over-the-wall mentality. When you write new code, ideally, you should be responsible for its health and well-being in the world. You should care not only for bringing it into existence, but also for shepherding it through testing and validation and vetting, making it available to your users, and making sure that it works well for them. But being able to just pass it off to a DevOps engineer who wasn't involved with the development and doesn't know what they're putting out there completely disconnects you from the code that you've written and makes someone else responsible for code that they know nothing about. Build nights like this also are stressful because it feels like the stakes are way higher than they actually are. Typically, we're motivated by healthy pressure that we feel intrinsically when we work on something that we care about. We feel empowered to make a positive impact for our users when we have the support of our team. But when a bug found in a deployment stage means a delay for everyone on the team that's waiting for you, this healthy pressure is suddenly replaced with this negative pressure when our motivation becomes a fear of letting down our coworkers or being seen as incompetent by our peers. And perhaps the worst part of this whole setup is that they're really not very inclusive. It kind of takes someone with a fairly specific lifestyle to be able to afford to hang around the office until all hours of the night all the time. Now, for us at the time, for a long while, we were actually, a mostly young group of 20-somethings with not very many responsibilities outside of work. We lived all within a short walk or subway distance from the office, and were willing to burn the midnight oil on the regular. But not only is that probably not the team makeup and work-life balance that you want to optimize for, it simply does not scale for hiring diversely. But notice most of how I talk about the issues that we faced weren't really focused on technical details or implementation problems. The problem wasn't getting the code to our servers. The biggest points of failure that we were identifying were actually around how the process impacted us and our users. So resuming the narrative back of Behance's deployment history, eventually one day we were having a hackathon in the office, which was just a day where we could devote our time to whatever project we felt would be fun or perhaps useful to the team. And some of our dev team engineers were just completely tired of our fragile build processes, and honestly, we're just sick of having to stay late all the time. So they sat down and they came up with a set of goals and tenets for how deployments should go, and actually set to work on building a platform that would finally move us to true CI/CD. We solved the problem in two ways. First, we defined a series of best practices that were designed for developing and deploying safely and with consistent results. And second, we put a strong emphasis on good UI and UX of the actual deployment platform interface so that we could make it approachable for a developer of any skill level to actually use. And we immediately gained a ton of benefits. Our peer review processes became more thorough. Our automated testing and linting suites became more refined and effective. We reduced almost all of the friction that comes from having lots of engineers working in the same one code base. And actually, we found that overall, with these checks and balances in the process and a clear UI to help easily move the developer through the deployment process, that these things meant that the engineers felt more secure and had higher confidence in their code changes and felt empowered and confident to continue doing that. We also found then that across the board, people were actually happier. Our engineers felt more career satisfaction by being able to get their code out into the world faster. And not only that, but our product managers and other stakeholders were happier to see greater stability on our website and more rapid iteration of our products. And finally, of course, our DevOps engineers were happy that they finally had freed up resources to work on actual ops tasks rather than just moving code from server to server. So the first thing that we looked at was development safety. For us, every engineer forks the repo and works within whatever branches they want in their own fork. What that means is that every developer now works in their own basically isolated detonation chamber. They're consequence-free playgrounds. You can mess up the branch as much as you want, delete it, rename it. You start over. It doesn't matter what you do or how bad you mess up the git commit history. Nobody ever has to know what goes on in there. Then, because everyone works on their own fork, that means that we can lock down the upstream repository so that it only contains approved code. This is nice because this model is also proven through open source software models, and it kind of works well because it reduces clutter, meaning that no one has to be responsible for managing any complex branching and release models. A big thing that we do is that we build features behind a feature firewall. This enables or disables different parts of the website for our users, which means that we can deploy code in small pieces even when it's not yet ready for public consumption. We can do that without fear of negatively impacting the user experience or causing problems for the other developers. Interestingly, it then also means that our designers and other stakeholders can actually test new features in a real-world environment before it's necessarily ready to be opened up to the public. Now, of course, production is not a development environment, but environments do impact how features behave and work, and it does reduce the risk of breaking something if the change is experimental or high risk. On the deployment safety side of things, this then means we can do smaller change sets. Feature flags allow for smaller pull requests, even for new features, since you don't have to have the feature fully complete in order to deploy to production. Then, since pull requests are smaller, that means that peer reviews can be scoped to code domain experts. And that ensures then that your changes are reviewed and approved by people who are actually the most familiar with the code. Of course, smaller changes also generally mean smaller risk and enables you to deploy your smaller pieces earlier and more often. In turn, this then means now that a pull request is actually the atomic unit for every build deployment. Only approved pull requests can be deployed, and you need to have at least 2 engineers approve your code before it can go up. This is a super important part of the process, since peer-reviewed code generally produces fewer defects, but also the process of peer reviewing encourages more collaboration amongst your team, which is always good. Because we're using automated tests for style and formatting checks, that also means the reviewers can actually focus on the substance of the pull request rather than keeping an eye out for nitpicky things like spacing. As an aside on top of all of that, we actually have a rule to just be nice in every peer review that you do. We need to be cognizant of our colleagues' efforts and tend towards the positive rather than the negative. It can be easy to forget this sometimes if we're reviewing a pull request where we're asking for a lot of changes. But the truth is that, compliments release endorphins. They make us feel good, and in turn encourages us to do more good work. CI is required to pass at every step of the deployment process, starting from when you open a pull request in GitHub. If anything in the suite fails at any point, you are blocked from moving forward. And now the other side of that actually is that stage and production both ask for manual verification of your changes. I think this point is actually really critical. Automated tests stop being useful at the point where reality begins. In real-world behavior and real-world scenarios and variables that stress the actual usefulness and behavior is our code out in the wild. We're humans building products for humans, and the automated tests can only tell us so much. So sometimes we just need to be reminded to actually step out of our shoes as developers and use our changes as a user would use them. We also keep an evergreen master. What this means in practice is that your code does not get merged into the master branch until after it's made it to production and has been confirmed by you. In Moonbeam, what this means is that there's a giant blue button that says, "Mark is good." And this means that the code in master always matches exactly what's in production, which then leads to really big benefits to providing safer rollbacks. Let's say you do find a you do find a bug once you get to stage or even production. Since the bad code still has yet to touch your master branch, a rollback means a simple redeploy of the last known previous good build. And this gives literally everyone peace of mind. There's a ton of checks in place before you get there, but the reality is that sometimes still bad code is going to make it to production. We're humans, it happens. The important thing is to make sure that when it does get there, it's not a big deal that this has happened. As the engineer responsible for the code, you know that you can nearly instantly roll back your changes without it having ever affected the main code base, which in turn means that you're not affecting any of the code that your coworkers are working with. As someone on the DevOps team, that means that you know you don't have to worry about being called upon to resolve someone else's commit issue. And as a product owner or stakeholder, you can sleep easy at night knowing that bugs are less likely to linger in full view of your users. So while those are the tenets and processes that we put in place to ensure smooth deployments, the other side of this coin is the actual UI that we've built to run the deployment. One of the most interesting things I think about Moonbeam is that we put a really strong focus on design and having a good, intuitive UI and UX. You should feel good about using the product. Deploying to production is scary enough as it is, and your energy should be directed towards creating the best possible product for your users and not towards being scared of accidentally breaking the website or embarrassing yourself in front of your coworkers. And this presents a lot of interesting challenges, in particular that good UI and UX actually is pretty invisible. If we look at this Jenkins screenshot as an example, this form is pretty overwhelming. It might be hard to see, but there's some fairly deep technical jargon in the options here. It's not immediately clear if there are other steps after this. And quite frankly, the fact that there's a question mark after every single step of this form is a little bit concerning to me. For something as critical and complex as deploying code to production, we need a good design that eliminates this kind of friction in order to feel confident in effectively deploying our code. So I feel like I'd be remiss to talk about having a clear interface without actually showing what our implementation looks like, but this also isn't really like a product cell, so I won't do a comprehensive walkthrough or anything. But what I mainly wanted to show is that we wanted to put an emphasis on removing the nuanced technical details of building and deploying with a simplified interface that just makes the relevant information that you need and the actions that you can take clear, while providing status updates and reminders to actually check your work throughout the process until your code is finally live. So while this whole thing started as a hackathon that only a couple of our engineers were working on, it's actually grown to be a first-class citizen in the product ecosystem of Adobe. It has a dedicated ops team to work on the systems and infrastructure that actually power it, and we get organizational support that actually encourages that. And not only that, but it also has a designer and front-end developers who can focus on providing the best possible UI and user experience for our engineers. Like any standalone product out there, we can file bug reports or feature requests for it in GitHub, and we also have a Slack channel that anyone can join to talk about things that they find or want in Moonbeam as well. And probably most importantly is that we all use the product. The Behance team is still using Moonbeam to deploy all of the code for our web products to production. Some of the Moonbeam team actually still sits among the Behance dev team. And what, interestingly, this often means is that the Behance team sort of becomes the front line for dog fooding a lot of the new features that get added to Moonbeam. Sometimes we are the ones even who are asking for them in the first place. The other fun thing is that the Moonbeam team actually uses Moonbeam. Since it is a web interface, Moonbeam actually deploys itself. The user feedback loop on these products seriously could not be any tighter. We call it Moonmaker, and I've used it, and it's really wild to deploy changes to the product that deploys your changes while you're deploying changes to it. It's really trippy. But what this all ultimately means, having this close communication loop, is that we are constantly able to check ourselves and our processes and make sure that we are continually making sure that we are maintaining empathy as the foundation for our effective deployments. Thank you.